Hello, outstanding kids. Welcome to another exciting ICT class. I want to welcome everyone back to class because we had fun in our last ICT class where we looked at Scratch programming. And we said that Scratch is a block-based programming language that helps kids to code. Now, would you like to start coding? I bet you will like to start coding. But before we start coding, there's something that you must know before coding. Our topic for today is follow the algorithm. I will say it again. Follow the algorithm. Now, in this class today, we are going to be looking at the meaning of algorithm, examples of algorithm, and some types of algorithm, in which we will also look at the behavior block. Now, before you start to code, there's something you must do, and that is writing an algorithm. An algorithm is seen as a step-by-step approach to solve a problem. It's just like your daddy or your mommy wants to build a house. Before building a house, they need to have what is called a plan. The plan is designed to make sure that whatever is in the plan, that is what they are going to be building. The kind of plan they have, that is the kind of house that will be built. Now, when programming, before you start to program or put a scratch together, you need to have what is called an algorithm. That is why algorithm is seen as a step-by-step approach to solve a problem. Now, you want to create a program. The first thing you need to do is to write the algorithm about the program you want to create, so that in case you find out there is a bug, it will be very easy to debug. Some importance of applying algorithm in a program include it makes our program orderly. Yes, when you create or write an algorithm before creating a program, your program will become orderly and it will be very easy to find or detect bugs. Another importance is that it helps us to plan for a program. And before writing it, it is also seen as a guide for programmers. So you see, algorithm is a guide. After drawing the plan, you use the plan as a guide to help you to program. We have so many examples of algorithm. Now, before coming to school this morning, you also followed a step-by-step approach, like you woke up in the morning, you had your bath, you greeted your parents, you wore your clothes, you carried your bags, carried your food flags, you entered the car, and you drove down to school. You greet your teachers, and you sat down in your class. That is a step-by-step instruction. That is a step-by-step approach for you leaving the house and coming to school. Also, how many of us love Indomie? Now, before preparing Indomie, we also have algorithm for that, which are, let's see if we can get it. Yes, you arrange your pot, put your water inside your pot, put the fire, put the pot inside the fire, scatter your Indomie, put the spices, allow it to dawn for some minutes or boil for some minutes, then it is ready to go. So you see, all we do have a plan, which is an algorithm. So the same thing applies to programs. Programs also have algorithm. Some examples of algorithm are building a castle, harvesting a pumpkin, getting the flour, finishing a task. You can add your own examples, but these are some few that I can give for now. We also have some of these examples in our program. Let's see one of these examples. Now look at this bee. For the bee to get to the flower, we need to write an algorithm. So let's see. If this bee move forward once, you have an algorithm, which is move forward again, and pick nectar. move forward again, and pick letter. So let's see. Move forward, pick letter, move forward, pick letter. So you see, this is one algorithm. And this algorithm was written before we are able to create this program. Let us see another algorithm. Now, if you look at this is an angry bird. Now, let us see how many move forward this angry bird will take to get to the pig. Let's see. Move forward one, move forward two. So you see, we wrote two algorithms. Now, let's see one more examples and see what we can do. Now, look at these scraps. Wants to get to this knot. So how many move forward do you think it will move? Let's see. 1, 2, 3, 4. So instead of us to put move forward, move forward, move forward, move forward, I just wrote an algorithm for writing repeat move forward 4 times. So we have move forward 4 times, turn right, turns right, repeat move forward 4 times. You see? So this thing that I wrote is an algorithm. And let's see if we can take one more example. And look at this other example. It says, for this angry bird to get to this pig, let's see. Move forward 1, move forward 2, move forward 3. So I move forward 3 times, which is the repeat. Turn right, move forward 1, and move forward 2. So you see, I wrote the algorithm before I'm going to be able to program it in my code studio. So algorithm is very important as a programmer, because if you have an algorithm, your program becomes easy. Now we also have something called a behavior. Now Scratch uses a behavior. A behavior is an action that a sprite performs continuously until you tell it to stop. Any action that a sprite performs is a behavior. So let's see some importance of adding a behavior to our blocks. It helps to control our program, and also it helps to give an action to a sprite. Not to worry, we're going to discuss more on sprite in our subsequent class. But before then, let's take a recap of what we've done so far. We talked about algorithm as a step-by-step action or instruction or approach to solve a problem. And we said that algorithm is very important. Before coding, you need to write an algorithm. And we say behavior is an action that the sprite performs until you tell it to stop. And that is where we'll stop in today's class. I believe we had lots and lots of fun together. Don't forget to do your online assignment and your quiz. We'll see in our next class. Bye.